What is dimensioning? What are dimensions? And how can they help us teach and learn core academic content? Let's first start with a definition. According to Webster's online dictionary, a dimension is defined as, quote, a range over which or a degree of which something extends. Hence, by placing any list of quantifiable entities on a line of continuum, you can compare their properties in a line of progression. Customarily, things of greater value are placed on the right and things of lesser value on the left. In practice, any quantifiable variable can be assessed in a line of progression. This process is vital to classifying the interrelatedness of properties and variables of any information schema, because through it, the mind can contextualize meaning and measure when assessing each data point. If all of these methods can be achieved through the use of one dimension, think of what can be done with multiple dimensions. Let's examine some commonplace examples. When we place data on a two-dimensional plane, such as the Cartesian plane with its x and y axes, we come up with an official chart or graph. We can see the use of these types of data tools frequently in everyday life. Yet do we truly understand their deeper embedded logic and applications? When measuring the financial performance of a company, the x-axis, moving from left to right, most often represents the passage of time, whereas the y-axis reflects the monetary value of the company. This enables us to present all data points in two distinct characteristics, this case being time and money. So therefore the value can all be assessed, showing the financial health of the firm. In many instances, time acts as the independent variable, hence is placed on the x-axis. It moves only in one direction and is not under our control, whereas the monetary value rise and fall, and hence is influenced by human factors. The same logic is used for scientific data, such as controlled experiments or measuring weather patterns. Another example we may not commonly yet often employ in such structures is musical notation. Once again, time is reflected from left to right, the G clef, and pitch goes up and down. In all these instances, multiple properties can be assessed and presented with a structure. Musical notation can fully explore synesthetic or cross-modal dimensioning of this process, for it translates audio information directly into visual presentation. Further detailed shorthand notes, G clefs, accents, etc., show the composer numerous characteristics of each note. Hence, spatial dimensioning can be further enriched with other visual symbols and metaphors, shapes, colors, and other corresponding notations. Likewise, in devising sense-based digital teaching software, employing an assortment of multidimensional techniques in concert with other strategies like color coding can be especially useful. I would suggest assigning the most quantitative variable spatial properties, leaving somewhat more qualitative information to be presented with things such as color. We can also add a third dimension, the z-axis, going from front to back to get even greater variables. Let's examine the geometric applications of the logic of dimensioning and how it can be used to clarify the patterns of our world. The Pythagorean Therem holds that the length of hypotenuse squared equals the sum of the two remaining sides. Proof of this efficacy can be found in turning each line into a square and filling them with liquid. The amount of liquid filling the squares based on the hypotenuse angle is equal to the volume of that hypotenuse. Therefore, we can glean from this experiment that the square literally means turning the sides of the line unidimensional, and turning them to two dimensionals form the shape of a square. This helps visualize the critical component of the core of mathematical functions and the nature of their operation. How can we understand the application used devised for digitally based sense-blended teaching software. In presenting a form, function, and pattern to core academic content, we can assign these spatial dimensional properties to compare the nature of information. Of course, this can be readily applied to mathematical instruction. We can address addition, subtraction on the x-axis, and then add y-axis for multiplication, division. For every major modality in this process, learning can easily be gamified to enjoyment and engagement of students. We can simply add point systems, basic plot lines to discover, for example, treasure, or very treasured places to convey the patterns of information, i.e., which cobblestones hide the treasure of Batman and to stop Dr. Octopus, representing patterns of multiplicable patterns. With the emerging technologies such as augmented reality, it is easy to see how various narratives can be built around sensory learning if numeric patterns, demonstration of logic of mathematical functions can be presented in spatial dimension and color codes. It is not difficult to extrapolate storyline connections encompassing these models.